Glad you're here, sir.
What was your name?
Jonathan Boyman.
John.
I'm Susan. I haven't been here.
Well, Susan, welcome back. All right. Is anybody working on any projects or they're shooting for any of the certificates right now that they want to tell the group about? Well, thank you, Darcy.
Now, is that as opposed to that spot? As opposed to that? You said there's a lot of good ones right now. I'm being flippant. That's all I know how to do.
Darcy, you want to smack him upside the head? I'll do it.
I can see stars.
Yeah. Huh?
All right.
Yeah.
Go ahead, Carl.
Display will be at after the festival, March 4th and 5th, and March 11 and 12. The weekend in March.
And that's going to be where at one more time?
At the Y Mountain Methodist Church. You go down
The Y Mountain Methodist Church.
Right with that church is the Daffodil Festival.
Okay.
Yeah, that's the one that does the daffodils, right?
Yeah.
Yeah.
Well, I know that.
All right.
I'm working on
anything
a.
else? Go ahead, John.
I said I'm working on a 6-week exoplanet data processing course through the AAVSO.
That's awesome, man. You're gonna have to keep us updated on that.
Yeah, I'll keep you updated. It's been really interesting so far. It's hosted by Dennis Conti, which is one of the authors, developers of the Astro Image J processing. It's a neat course. I've learned a lot just about the exoplanet discovery process in general from the little bit. But yeah, I'll keep everybody updated as I learn more.
Thank you, Sean. Is anybody else working on any certificates or?
I just have my own little project where I'm continuing using different filters, filter combinations to see that's in the portal class 7 or 8 of where I live, and then in other locations here, make the comparisons of how it affects color and how you shoot it. So, after a little while.
That way we can work on the light emissions that way.
It's called fighting the light emission.
And me and Michael, we've been working outside here a little bit on the getting other places for viewing remotely from here. Everything from the soccer fields to Two Rivers Park, the ballparks up in Sherwood. We're working on hopefully on was one in Conway.
Well, we don't know. We haven't found one. But that's why I'm hoping Sean will let us know.
Or Sean up in Conway, hopefully will let us sneak up there and view for a while.
Yeah,
And,
absolutely. Anytime you want to come out, just let me know.
And we're also working on deciding what we're going to do about the eclipse next year. So, and you'll hear a little bit more about that coming up. Anything else? Well, I'm gonna go ahead and turn this over. Alan, would you like to do your presentation?
Yeah, I had a quick thing.
Okay, John.
Can I do my quick thing?
I'll give you
All right.
your 5 minutes.
Do
You
my
said.
quick thing. Well, a couple of things. When you, those of you that have done comet photography in the past or observation, you know they move very quickly. When you do say 2 hours of exposures, they move across the whole field with your camera down. They're fast moving exposures. Well, one of the tricks you can play is you take a couple of your frames spaced appropriately apart and put them together. I have done. I pass this around. Anyway, I posted this to the Facebook thing. So it's not really 3D, but it kind of is, because the comet is moving against the stars are still. The comet's moving, and when you put them in a frame like this, it actually makes the comet look like it's moving. So that's some people are better at 3D than others, but pass that around and see if you can see it. The other thing is this is called an orrery, and I've always wanted to build one, and I thought it would be easy. And but wow, there it is. It shows the Earth axis always is pointed the same direction. By the way, some of the RoboKit things that you can get with the laser cut gears don't do it properly. They actually have the Earth axis recessed, which doesn't always point in the same direction around. And the moon goes around in the correct direction. I had to make changes for that, so that's why this gear is just friction grabbing. It only goes around 4 times as opposed to 12 because of mechanics, not because of negligence. No, that's interesting. Somebody actually makes a little kit of solar system gemstones. So these are like different semi-precious stones that are polished in the sphere, and they sell them as a solar system kit. So that's actually Saturn, but and that I forget what it's supposed to be. The thing is, I had to drill them with the diamond. It's stone, but I wanted to mount them on those. Yeah, thank you. It's so you can take a look at that. Well, they make what they call a grand. That's all the planets. Usually not all of them. But that's beyond the scope. That's it. I'm done. You're awesome. Oh, did you see it?
Can everybody hear? How about the people at home? I guess it works.
Yep, you're coming through
Okay,
loud and clear.
We can hear you.
Sounds good. My name is Alan Lee. I've been a member of the club. I can't remember how many years. It goes back a few years. But I'm a retired meteorologist and spend most of my time looking for things to do. Tell you, this pandemic was something else. For 2 years we hadn't done anything. It's nice to be back here, see all these friendly faces. During that 2-year time, I was casting about things to do while I was at home. So I figured, well, let me try jigsaw puzzles. So I went over to Toys R Us, found a box that 5 to 8 years. So I figured that sounds good. But I finished it in 1.5 years, so I don't know what the big deal was. But would have taken John 2 years. And anyhow, one of the things that I've been doing for a good little while is 3D printing. And I got inspired to do it because I needed some parts for my C11. And the only way to do it, since it didn't make the part I wanted, was to do it myself. And Chris, um, Chris had a 3D printer. And so that, he told me a little bit about it. So I decided, okay, that's something I think I could handle. So I bought one. Well, we got the printer, started making things. Well, there's different things you can make with it that are astronomy related. And one of the things you can do is go to a NASA site, and they got all kinds of models there that are 3D ready. You just get the 3D model, you put it into what's called a slicer, and that makes it into what's called G code, which is a computer generated code that tells these machines how to operate. And I don't know if you've ever seen a 3D printer operating. What they are, they're probably closely related to these hot wax, where you put the wax filament in and you squeeze it and it comes out, glue gun. That's about what they're like. And well, it's similar to, it's really plastic, or a form of plastic. But that's one thing you can do. You can use your already built models that you can get online. You can build your own and create 3D shapes. And then whatever you can build, you can slice it and put it in your machine and it'll print it out. They're not without trouble. You got to fiddle with them. I started out with what's called a Creality 3 printer. It was really entry level. It got about 4 years ago, and they're resplendent with problems. First of all, it's got a aluminum bed that has a tendency to warp. So you're constantly fiddling with trying to overcome the warp and get it so it'll print. And it does work. I wound up doing a bunch of projects for the library project, the telescope project. And Lori, how many of those finders did we make, Rocky? I can't remember. Yeah, there was a bunch of them. Yeah, Rocky's got a good supply of them. If you wonder what 3D filament is, this is some that's left over. This was from one of the filament is left over from a project that we made. I don't know, it was for a telescope that you had, and that was a big deal. It used the full volume of the printer, but you can take a look and see what that stuff is. That's called PLA, which is polylactic acid. And when you look at the description of how they make it, they take corn and starch and a bunch of other stuff. It's almost, and then they let it ferment, and it's almost like making beer, the way they describe it. But then they do some mechanics with it and squeeze it out in these long strings, and it's re-meltable.
So this 3D printer melted.
Yeah.
Is that hot?
Yeah, there's a hot end on it. You run this into this hot end, just like a glue gun. And it gets hot and it squirts out. And the little filament that comes out is 0.4, if you got a 0.4 millimeter nozzle, it comes out in this little tiny string. These filaments are 1.75 millimeters, and everything related to 3D printing is in millimeters. So you kind of have to get used to it. But they sell those things in 2.25 pound rolls, or 1 kilogram roll, for about, well, price has gone up. They're about $24 now. You can get some cheaper, but you have to kind of fiddle with it for a little bit to see what works. Well, I got inspired to make a few models of things. One of the things that I've shown here before is a 3D model of Copernicus. And it's actually, this is from the NASA site. It's it's 3 times vertical expansion, because if it was just single, it'd be essentially just a flat piece of plastic. So they expand it vertically so that you can see the relief. Yeah. Yeah, that's one project that I'm going to take on, except it would probably take a full roll of filament and a couple days to print it out. You don't have to paint it. What you do is you put a light in it that shines through. It's called lithography. And you can do any kind of picture that you want and put a light behind it, and it looks like a photograph. But not, it'd be as big as I can get on my build plate, which is going to be about 8 to 10 inches. Yeah, a couple of days to do it, but go ahead and look at that. To scale?
If you did that whole thing, would be to scale?
Yeah.
Oh, wow.
Yeah, and I've seen pictures of people doing it, and it looks like a full moon when you look at it. Yeah. Yeah, and even for fully sighted people, if you look at the little mountains in the center of the where the rebound of the magma came up, look at that. Those are 2.5 times the height of Pinnacle Mountain. So it gives you some idea of what you're looking at. And it's kind of fun if you got your camera with a flashlight on it, you can shine it from the side and then move your camera, and it's almost like watching the Terminator move across. So you can play with that. Another thing that I figured to do, and I had to do it in 3 pieces because it would fill a build plate otherwise. This is Valles Marineris from Mars, and it's the Mars Grand Canyon. And you look at it and you figure, well, yeah, it's a Grand Canyon. We got one, but this one runs from California to New York. Give you the size of scale. So it's pretty interesting. This is another model that came off of NASA. NASA's got a whole bunch of this stuff. How deep is that? I got some right up on the back. It may say on that, but I don't remember the depths. But again, it's done vertically. Expand. Oh, well, it's in 3 pieces. I'm trying to think. It probably took just as I recall, somewhere on the order of 5 or 6 hours for each piece.
So your machine can only do a square to 30%.
Well, the build plate is about like that. It's almost a foot square. And this thing, because of the scale, I mean, you can scale these things up, but I didn't want to do that because I could get a mismatch. I just wanted to keep the original. So, well, that's what you use is glue.
Oh, you actually glue it.
Yeah,
Okay.
it's glued together.
All right.
And I use super glue on it.
Okay.
There's people can use other stuff, and it depends upon the material you're printing with. There's other materials that you can use. This is, yeah. This the thing with PLA. And I did make one of these. I don't remember if Carl had shown. I think Carl had shown one of these solar sundials that actually prints out the numbers.
Yeah.
And I made one of those. Yeah. And it turned out pretty good. And it's made out of material PLA, but you don't want to leave it out in the sun or out in the weather because PLA deteriorates. So as long as you use it at night, you're okay. But PLA is, I've never had a problem with them coming apart or anything. A material called PETG is much stronger. You can print with that. And Jim Dixon got a printer, and he started out with PETG, which is one of the harder materials to take care of. PLA. Yeah. That's all I've used. I got 2 rolls of PETG with my new printer, but I haven't used them yet. One of the other things I've used is I made is a phone holder to go on your telescope to take pictures with. Put the phone in here, and you can do micro adjustments, get everything lined up. And it's all printed out, different colors of PLA. But that was something else that I found on a website. Occasionally I do some design of my own, but it's not too often.
You didn't have to design that. It was already.
Yeah, it was already made up. I had to figure out how to put it together. That was the hard part. Our project for the libraries, they started using these as finders for the scopes, because you use the Celestron thing and it runs out of batteries and gets out of adjustment or whatever. But Rocky got me the plans and sent these over, and we made a bunch of them. And recently they just changed the design on the scopes that they're buying to use a dovetail. I'd printed out these dovetails that you just mount to the old scopes. And, just use the screws, you just attach it in, put it in there and screw it down tight, and you can move around a little bit and line it up. You look through that hole using these low power scopes. If you get anywhere close to the object you want to see, you'll see it in the eyepiece. So it's pretty broad. But that's another neat little project. And we printed a ton of those. And
We're starting to put new library stuff. We're starting to put them on before we even send them out. Because we got that time, so much.
and for people that got jobs or want to do solar observing, you got something to put over the front of your scope to block the sunlight. Or if you're doing projection stuff, you can use this little solar finder. Got a pinhole here, and it projects the pinhole onto the this little crosshair gizmo, and it should work. It's highly adjustable. So for anybody wants one, Rocky, I think I gave you one, didn't I? Yeah. So they're 2 cool little things. I mean, that's something, somebody had that on the website, so you can use that stuff. Let me see. Well, let's get to the fun stuff. Set this down for a second. Like I said, when I got tired of the jigsaw, I decided to move on to something else. So this is a 3D printed telescope. Everything you see in gray is 3D printed. I didn't do any design for the base telescope. There's a guy online I've got, if you're interested in just seeing how they do it, I've got a few sheets up here that's got references where you can look up this stuff. But the deal with the scope is, and I think this guy's a college, he's made some
comment about, can't spend all its time designing stuff in the class once in a while. But, this is a 6-inch scope, 750 millimeter focal length. Parts we had to buy, I had to buy the mirror. I had to buy the Frankfurt binder.
You couldn't 3D print the mirror?
Not yet.
Okay.
But you can, but you won't see anything.
Yeah.
That's the downside.
Oh, yeah, yeah.
But, printed the unit. And most of the stuff, like I said, most of the gray stuff is came on the model. These are aluminum struts. And in the original design, the guy just had 2 struts. He made it so you could have 4, and I figured, well, 4 would be more stable. Probably wouldn't have made that much difference.
I did pick those up.
I did
From
print,
Depot or something now.
I'm sorry,
Where'd you get the struts from?
got them online, Amazon.
Like, is it tubing?
The square extrusions.
Oh.
If you get a 3D printer, that's all 3D printers made out of this stuff. They're all
So is it, it's a plastic material?
No, it's aluminum.
It's aluminum, but square aluminum.
We're aluminum struts. Now, there are designs for a telescope where a guy uses fiberglass rods, but those got a little more expensive. I decided to go cheap. One of the downsides about going cheap is I bought mirror I got off AliExpress. This is Chinese. Everything's Chinese. So I got the AliExpress mirror, but it's a spherical mirror. It's cheap. About parabolic. But anyhow, I may get around to doing that sometime. But the parabolic mirror would have been a couple $100. I got it. Focuser came from AliExpress. It worked fine, except it came with a curved base plate. The curved base plate doesn't work on this design because it's flat, so I just measured the diameter, printed a flat base plate, put it on there. So another modification. The other thing that I've been doing with it is using these are telephone holders. They're designed specifically from an OtterBox outer. Most of the time when you get a phone holder, you got to take all the stuff off. Just use the naked phone. This thing, it fits with the holder on it. The neat thing about it,
Alan, how much of that pattern is something you designed and how much did you get?
all the gray that you see here is offline.
Okay. So somebody designed all that.
Yep.
Printed it out and adapted it.
Yeah, and presumably with this design, if you got a parabolic mirror with a 1500 millimeter focal length, just along the tubes, it would work.
Yeah.
Or my solution is I use a borrow. Yeah, I built the now. Interesting thing about that is, I do a little bit of work with it. I use this. This was a failed print. We got that far and then stopped. So I used this pattern so that I could make the cutouts. And I figured, well, that's pretty good. I'm good. I can use my jigsaw and just went around. Trouble is, I went around and over. It had too much flopping, so I had to put shims in. Like scope the hole. I got it together. I built this folder down here. Also got I just carry my lenses down in here in a box. It's got a homemade lens. Downside I found is that for some reason I can't hold pollination on the center or on the secondary mirror. Every time I take it out, I got to fiddle with it. Both scopes got a decent scope. Secondary is pretty big. Then you just got to fiddle with the primary. You do have to buy a bunch of little parts.
Do you take it apart?
Oh, it's it. No idea.
Well, when you like the journey, I have to pollinate every time, too, because it's the bar and it bounces around on the way up here.
But you have to mess with the secondary.
Yeah, I do, a little bit. And, you know,
Yeah.
just a couple hours.
This thing's never really on that well.
Yeah, 'cause it's one of those laser pollinators.
Yeah.
Stuff like that.
Did you
get this to sit on?
I made the lens holder. I made these little brackets here to keep it from falling off.
Is that just a table that you get this to sit on?
No, this is a table I use all the time to hold stuff. See, wherever you put it's pretty good.
So have you used the telescope?
Yep. It's, I don't like, when I look at planetary, the really bright stuff, I kind of double images. I think that's in part because it's spherical mirror. It's just a hair out. Parabolic.
What's the F ratio?
5.
Yeah, you need to steer it.
So, going to that happen. So, the mount operates at the bottom. It's on a lazy spoon. It was no good. Trouble is, it's too good. So I had to build a little break on it. Put it in there so it rubs on the bottom of it. That way it holds. And if it's a little bit downhill or something, this thing would actually move. So it does hold there. One of the other things that I got off of the website on Candy, it's called Astronomy Technology Today. Online astronomy magazine. So they used to send out print copies, but it's all online now. They talked about this application.
I didn't use that, did I? I didn't use this application and mount it on the scope, and it makes it a push to scope. So you can select whatever object you want to look at, and it will tell you which direction to move it, right or left, up and down. And they even had a version that I went and spent another $2 to get the kind that goes over to the Apple Watch. So I can be sitting over here, looking at something there, and it'll tell me which direction to push it. To a degree, yeah. It just, and Celestron does make an application, but I've read that it has a tendency to fail a lot.
Do you have to tell the phone at where it's mounted and relative to the angle of attack for you?
Yeah, ideally, well, the first thing you do, no, you just level your base. It's got a bubble level in it. Level the base, and well, you can't see it here. I'll just hold it up. See, it's got that little target there. And in my backyard, I can't see Polaris. I can see a few other. I can see see a few other stars that are usable. But what it does, it uses a general compass, and it tells you if I want to go to look at Polaris, it tells me which direction it probably is. And so I just move the scope and then tell it it's calibrated. Then you go to whatever you want to look at. And if you get close, then you can move to the object, center it, and tell it to recalibrate. And then you're on. So it'll hold. So it's similar to the to like a two-star alignment. But if you could see Polaris, you only need one star, just Polaris. But this is a cool little thing. If you got a Daub, you might want to look at it. And it's called PS Align. Yeah. Yeah. It's strictly and once it knows where Polaris is, you can pretty well point it to anything else. And in my backyard, this thing says it's Bortle 6. I guess that's bad. But using this, I can find all sorts of globular clusters, planetary nebula, 57, and it's just a matter of using this thing to point it in the direction. And of course, you know, if you use a 10mm lens, that's 75 power, pretty wide, so you can see, get pretty close, and I found it's just about always centered. So once you get it centered, then you can go to your shorter focal lengths. That starts off with the magnetic, senses the magnetic field of the Earth. And I think we're what, like 6 or 7 degrees off true north. So once you get it close to a known star, and you point it at it and tell it to recalibrate, and then it'll hold it. So it's a cool little tool. If you got a Daub, that's a way to make it a push to without having to do anything else. It'll work with anything. So give you something to just take away.
Put it on the website. You know, the sites you went to get the program. This is great.
Yeah. Well,
I tried doing it.
it didn't work.
What happened? What app are you talking about?
The app, it's called PS Align.
Yes.
Yeah. And they got a real good write-up in Astronomy Technology Today. That's that online thing. You can take one of these sheets of paper, which gives you a reference. I'm sorry? Oh, I just pick it up and set it in the passenger seat of the car. Set this in the passenger seat. Yeah, if I had a baby seat, I'd put it in the baby seat. Yeah, yeah, you can use HOV. Yeah.
Your printed parts account for the extruded aluminum, like those are gantry parts?
Yeah, they're all,
So
it's all square holes.
okay, does it have a key slot too?
No, no, they're just square.
Okay.
And
You can use any square tube.
yeah, I don't know.
Carbon fiber tube.
Yeah, you could use something. It's just a matter, you got to secure it somehow. Put a screw through it. But,
That's 80/20 is the extruded profile you're using?
Yeah.
Okay.
Yeah, I think it's 20 by 20.
20. Okay.
I think they're 20 by 20 extrusions.
Okay.
And they make some of them 40 by 40 on some of the printers that you see. So there's and the extrusions were actually one of the more expensive parts. I can buy two, or I can buy 4 pieces of extrusion for, I think it was $30, $35. So by getting all 4 of them, I got $70 tied up in aluminum. $20. It took a full reel of PLA to make all the gray parts. And I got about 3/4 of the way through. My printer was acting up so bad, I said, "To heck with it," and decided to get rid of the Chinese stuff. And I went to, I bought a Prusa printer, which comes out of Czechoslovakia. And it's one of these things you put your filament in, turn it on, and it prints. You don't have to screw with it. I mean, occasionally you'll get a blocked nozzle, but that's because of the filament you're using. You have to clean that out. Yeah, different filaments operate differently in slightly different temperatures. You're talking about, most filaments operate 195 to about, on PLA, up to about 220 degrees Celsius, which is, I don't know. I can't remember what that is Fahrenheit. You don't want to touch the nozzle. I know that.
Does, if the nozzle is messed up and this is your waste, does the machine stop, or is it just melting stuff?
I see pictures of people all the time where something happened and they wind up with a big blob of plastic attached to everything. Or you get a lot of spaghetti. It just starts printing in the air, and you get piles of bird nest. So there's different things that happen. You know, they're not trouble free. You have to fiddle with them a little bit. But a few people got printers. I think Chris Lastly, he's got one. I don't. Danny, do you have a 3D printer? If he's
I do
listening,
have
he may have
one.
gone out to the scope.
Yeah, I've got one.
Yeah, and so Jim Dixon's got one. Cousin Darcy has one. Darcy and me we're related. We're both Lees. She was a Lee formerly, and I'm a Lee now. And we're related because both our mothers are mothers. So that's about as close as we got. So. Any other questions? Anybody want to? Yeah, that's what it's worked out. But.
So you were saying that there were some things for your Celestron scope that you couldn't get anymore on your printer. So what do? You take a picture of it and then the computer can then tell you how to print it?
No, there's different software packages you can get that let you design stuff. One of them is called let's see, it's Tinkercad. It's little. You just take a bunch of little boxes and put them together, and make a solid piece of something out of it. If there's something you want to design specifically, you just get your calipers out and you measure it out. And you want something square, you just put the square into the software, and then you tell it, make it 20 by 40 by 30.
Looks like an AutoCAD.
Yeah, it's a form of AutoCAD. And another one that I've started to use is called Onshape. It's a little more technical. Got to fiddle with it a little bit more. But there's some people go whole hog and get pay for the really expensive CAD software. It'll work. So if you want to talk expensive CAD, talk to John, because he'll buy one and figure it out.
I have a license through the hospital, but yeah, I don't know an AutoCAD.
But
I know how to work it.
But you can, it's got long learning curves on how to work that stuff. But Tinkercad's pretty simple. It's just blocks and squares and circles that you put together. And you can build almost anything you want. One of the first practical ones I made is I broke a part in the refrigerator. It's a shelf retainer, and it broke. And so I went online to see, well, I'll order another one. They don't make them, it's out of stock. So I just took my ruler and measured it out, because I had a good one still, but the broke one wouldn't function. So I just measured it out and used Tinkercad and put the little boxes together and dimensioned it out, and you just make your own little bracket. It still works. Hadn't fallen, bottles haven't fallen out of the refrigerator yet. So, I mean, there's practical uses for all this stuff. And I do a lot of reloading. Me and my son, and we make reloading or boxes to hold cartridges in. And you make them all sorts of different colors and that. Go out to the range, everybody will wonder what in the world where you got those things. But it's just, you know, it's just fun, practical things that you can do. But anyhow, you want to make a telescope, there's like 3 plans online where you can build them. And the guy that designed this stuff, he's also got one that he's making with using a CNC router that carves metal. So he's made a metal one of something like this. But I think if you're going to make something, yeah, see if you can find one that's maybe got an 8-inch with a longer focal length in it. And it, you know, they work pretty nice. Anyhow, now that I've inspired you, stick to jigsaw puzzles.
So we got a message up here. It's popped down real quick. But basically, Sean was saying that he does sell PLA. So if you're interested, get a hold of Sean Hartley. Did I get that right, Sean?
Sorry, I couldn't hear it. What did you say?
Did I get that right that you're selling PLA?
Yeah, I have
By the
PLA,
roll?
so yeah, I have 24 colors and a couple of hundred rolls. You know, if anyone needs filament, holler at me. I'll make you a good deal on it. Local Novus Terra PLA filament.
Novus Terra.
Thanks, Sean.
All right, thank you.
Yeah, but you do what I like. I don't remember. I had it right.
All right. Does anybody else have any announcements or anything like that? Other than me and Bruce, we were graced with getting to work with the, if I'm correct, the Regional Astronomical League, and trying to get some of their affairs in order there, which you'll be seeing some paperwork on voting. Yes. And so look out, you might get some emails from us on stuff for the group to vote on that before I think it's in July. They're going to be doing it down in Baton Rouge is the next Alcon. So and if right, but they're going to have all types of other stuff down there for options.
Oh, you can tell.
Okay, March the 18th. We're talking about a Messier marathon. Bring a cot, your telescope, sleeping bag, food, something warm, and try to stay up all night. Maybe you'll even talk Bruce into coming up and fixing breakfast if Bruce is on here.
I want, you know, a lot of people don't want to come up and spend the night, but they don't want to come up and stay till midnight. And there's a new and this is something that came out in the January astronomy magazine.
Right, so
They got a mini marathon. So you come out, you do a quarter floor. So right now you do the winter hexagon, and that do like a
little mini marathons until midnight or something like that. And just come up here and try and stay as long as you possibly can.
I think that'd be better than the whole, it's hard.
Rocky beat me by 6 objects last year.
Yeah,
You know,
that's because he was
stayed up.
taking, that's because he was taking pictures while he was.
Everybody else went to sleep. Rocky and I even were like,
And y'all know where y'all look.
I tried, but he's good. He beat me.
All right, folks. Well, in February 20, we think it's February 23rd is the, oh, wait a minute. Okay. There was a question from Michael here that marathon, it was on the 16th of March, 18th of March, excuse me. It's the 18th of March on that. And what, hold on one second here. Rocky, when is the, it's February 23rd. It, okay. It's the ANSA 101 observing. And if you haven't signed up for it, please get signed up.
They closed out for this one.
Okay. Okay. Well, then I guess they're booked out already, but that's just a reminder for everybody. Yes, Kat.
Yeah, yeah.
Send me a link.
All right. Do we have any other announcements, folks? All right. Well, thank you all for coming out. Wait a minute. Yes, sir.
Regular meeting next month, what time? I'll try not to be late since I volunteer for cook.
Okay. I think this is our last one, if I'm correct. That is going to be at 6 o'clock, and we're going to switch it to 7. I think it is next month. It will be on our calendar. If you don't know, you can go to our website and it has the listing on there. Oh,
Okay, the next meeting's on the 11th and daylight savings time changes that.
oh, okay. So, thank you.
You make a decision.
That's confusing.
Okay, so
Send out an email.
I just look in your email, because I will end up making a decision, since that is the night that daylight savings times does change. Thank you for correcting me on that, and I will have that posted here probably in the next day or two. Is there any other questions from?
And people who know about dew control put up presentations.
Yes, all you gotta do is sign up, speak to Michael, and we can get you.
Sean or Rocky.
Yeah.
Just let us know.
Any of them, and we can get you on the schedule to speak. And that would be wonderful.
And we, and,
I
and,
mean,
and, you know, if it's only 10 or 15 minutes, we'll have 2 presentations.
Well, I found out the hard way in my yard, backyard, that setting up and having it all ready to go and laid out, and you go inside, it's just everything was wet and ruined. It was the night. Yeah, man.
All right, well, folks, like I said, thank you very much for coming out. If I'm correct, the skies are somewhat clear out there. Go out there and take a peek in a few of the scopes, ask some questions. If people like me that do not know everything, if I don't have the answer, which happens quite often, I can usually point you towards somebody that does. All right. And they're always happy to share up here and give you a little bit of education on it. And thank you all for coming out once again tonight. Thank you, Sean.
Bye bye.
Bye.
Yes, sir.